Imagine a place where time stops, light is trapped, and the laws of physics break down. What if I told you that such places are real and aren't just a science fiction fantasy, and that one of them could be lurking in the center of our galaxy right now? Welcome to the strange world of black holes. To understand black holes, let's first look at how they're born. When a massive star, approximately 5 times the size of the Sun, reaches the end of its life cycle by burning all of its hydrogen, it explodes in a supernova. This explosion blasts off the outer layers of the star, leaving behind a dense core. Depending on the mass of the original star, this core can collapse under its own gravity, creating an intense gravitational pull. If it's massive enough, it continues to collapse until a black hole forms, a region so dense that nothing can escape it, not even light, the fastest entity we know of. The anatomy of a black hole is very intriguing. At its heart is the singularity, a point where gravity becomes infinite and the fabric of space-time curves infinitely. Surrounding this core is the event horizon, the point of no return. Anything crossing this boundary is lost to the black hole forever. The German astronomer Karl Schwarzschild worked on identifying the event horizon's radius of a special type of black hole known as a Schwarzschild black hole, or static black hole, which has no electric charge and does not rotate. The Schwarzschild radius is an exact solution to the Einstein field equations. It's at the event horizon that gravity is so strong, not even light can escape, making the black hole invisible to the naked eye. So, how do we detect something that we can't see? Black holes may be invisible, but we can observe the effects of their massive gravity on nearby objects. The first ever attempt at simulating a black hole image dates back to 1979, when French astrophysicist Jean-Pierre Luminet published the first simulated picture of a black hole surrounded by an accretion disk, relying solely on an early computer, mathematical calculations, and India ink. He anticipated that this model could apply to the supermassive black hole at the center of the elliptical galaxy M87. Decades later, in April 2019, the Event Horizon Telescope, or EHT, achieved a huge milestone. It captured the first ever image of a black hole in the galaxy Messier 87. This image revealed the shadow of the event horizon, surrounded by the glow of heated gas, finally proving that black holes aren't just theoretical, but black holes don't last forever. Like all celestial objects, they eventually die. One prominent explanation of their death is Hawking radiation. Hawking built on previous work by physicist Jacob Bekenstein in 1973, who predicted that a black hole has finite entropy. Entropy is a measure of disorder or randomness in a system. Bekenstein also predicted that this entropy is proportional to the area of the black hole's event horizon. In 1974, Hawking confirmed this result by proving that black holes emit thermal radiation, ultimately leading to their evaporation. According to this theory, black holes emit radiation due to quantum effects near the event horizon. Over unimaginable timescales, this radiation causes the black hole to lose energy and eventually shrink. While developing this theory, Hawking encountered a major conflict with the unitarity law of quantum mechanics, which states that information in a closed system is preserved over time. This issue led to one of physics' most famous problems, the information paradox. Hawking later justified his theory by proposing that the quantum pairs of particles and antiparticles not only carry the same information, but are also separated around the event horizon, with one particle radiated away and the other falling into the black hole. And just when we thought black holes couldn't surprise us any further, scientists revealed a groundbreaking new image this year. Building on the historic 2019 black hole picture, the Event Horizon Telescope captured even more details of polarized light and the magnetic field surrounding the black hole at the center of our galaxy, Sagittarius A star.